In this video, a practical distributed control method for cooperative VTOL UAVs to fly freely will be introduced. Drones are now becoming increasingly accessible to amateur and commercial users alike. A safety air traffic management system is needed to help ensure this newest entrant into the skies does not collide with buildings, larger aircraft, or one another. However, the traditional centralized control method of air traffic management is infeasible for increasing drones because of lacking scalability. In order to address such a problem, free flight is a developing air traffic control method that uses distributed control. To formulate the free flight control problem, a UAV control model and a filtered position model is introduced first, including three types of areas, namely safety area, avoidance area and detection area, used for control. To simplify the following problems, we have the following assumptions for all UAVs, which include that the detection radius, the distance between waypoints, and the distance between initial positions are large enough, and each UAV will land to the ground once arrives at the waypoint. The objective is to design the velocity command input for each UAV to guide it to arrive the waypoint, meanwhile avoiding colliding with others. The free flight control problem is formulated so far. Here are some preliminaries. Two smooth functions are defined for the following Lyapunov-like function design. The idea of the proposed method is similar to that of the artificial potential field method. Based on this idea, the Lyapunov-like function design, the controller design and the stability analysis of controller are completed. The proposed controller relies on the following three features. First, unlike the formation control, neighboring UAVs' IDs of a UAV are not required by the proposed distributed control. Second, a double integral model with the given velocity command as input is proposed for UAVs where the maneuverability has been taken into consideration. Third, the maximum velocity command in the proposed distributed controller is confined according to the requirement of semi-autonomous autopilots. The velocity command will not be dominated by the term of approaching to waypoint in the case of a UAV is very close to another. This can avoid a danger. The simulation has three parts as shown in the picture. Here, a scenario of 41 cooperative UAVs is simulated. The confliction between two UAVs has happened initially. This is to simulate the situation a UAV appears in another's safety area accidentally. As shown in video, the confliction disappears as soon as possible. Finally, each UAV can fly to its waypoint without deadlock and confliction with other UAVs. Further, the minimum distance among UAVs keeps greater than the safety distance. The experiment equipment includes a motion capture system, a laptop controller and 4 cooperative multicopters. During the experiment, these multicopters can reach its waypoints at 50 seconds, keeping a safe distance from other multicopters without any confliction. Simulations and experiments are given to show the effectiveness of the proposed method from the functional requirement and the safety requirement. That's all. Thank you for your watching.